Right. In base 10 number system, we have learned that there are 10 digits, including 0 up to 9. So these are the valid digits in base 10. And in base 2, 0 and 1 are the valid digits. In base 8, it is 0 to 7. And in base 16, it is 0 to F. In base 16, it is 0 to F. And these are the valid digits in each number system. Right. Then, so why we are using A, B, C, D, E, F in hexadecimal? So can you tell me the other names? Base 10 means decimal. Base 2 means? Base 2 means?
Binary.
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 Yeah. Base 8?
Octal decimal.
It's octal. Base 8, it is octal. Base 16, it is hexadecimal.
Hexa.
Yeah, hexa, or the short name will be hexa, but the more accurate one is hexadecimal. Okay, we have binary, decimal, binary, octal, and hexadecimal. Why we are using A, B, C, D, E, F in hexadecimal? What's the reason?
Because the same number repeats again and again.
Yeah, because if I am using like 10 here, that means the uniqueness of symbols will not be there. So 0 is unique, 1 is unique, 2 is unique, 3 is unique, 9 up to 9, all are unique symbols. But if it is 10, again I'm using 1 and 0 means it's not unique. I'm using this symbol and this symbol, which is not unique, in order to make this unique. In order to make this unique in Sinhala, we call ananya. Venas, anit symbol valing venas wenno. To make this unique, we are using A to F. Why we can't go like G, H, I, J, K likewise? Why? What's the reason?
Because again the numbers will be revised again.
Yeah, again, if we are going to use if you are going to use more than 15, again that is violating the particular number system rule. Because in number system, you know, the rule is it should be below the particular base. The maximum number in the number system is, yes, it is 1 below the base. 1 below the base means is base 10, the maximum is 9. Base 2, maximum is 1. Base 8, maximum is 7. 1 below the base. 1 less than base. 16, it is 15. 15 means F. Okay, we learned this, and actually today we have to discuss more about how to convert from one number system to another number system. So basically we will learn how to convert from decimal and how to convert from octal. Likewise, we will learn. So first of all, let me revise by giving you an example. Let's say you have 79. This is in base 10. Base you are going to write in subscripted way. Subscript kala tama liyanne me. Basically it's as a small letter with small letter subscripted. And so can you convert this number to convert this number to quickly do this to binary, octal, and hexadecimal. So can you quickly convert 79 to binary, octal, and hexadecimal? So what is the mechanism? If there are new students, let me repeat. What is the mechanism? We are going to divide by the base. So if it is binary, base is 2. If it is binary, what we are going to do? We are going to divide by the base. For an example, see this example. If number is 45, we are going to divide 45 by 2. Then it is 22. Remainder is 1. Remainder is 1. Let me draw remainder in another color. I'm going to write remainder in green color. This is again 22 divided by 2 is 11, remainder 0. 11 divided by 2, 5, remainder 1. Remainder I'm going to write in another color. 5 divided by 2, 2, remainder 1. Then 2 divided by 2 is 1, remainder 0. When you divide all the numbers and all the numbers are divisible, then all the digits are in binary. All the digits are in binary. Binary you have here 1 and 0 only. If all the digits are in binary after division, you are going to write from bottom to top. Bottom to top. Okay, remember it's bottom to top, this direction. You are going to read this number from here to here, bottom to top. It is 101101, 101101, and that's how we are going to convert and write. This is actually, you have to write 2 here, that is the base. Okay, so then if it is octal, how we are going to convert?
Okay, sir.
If it is octal, you are going to
From
divide
8.
divide by
8.
8 and write the
Divide by 8.
Yes. If it is a hexadecimal, you are going to divide by 16 and write the remainder. Don't take the decimal points. Don't write like 45 divided by 2 is 22.5. If you are going to divide like that, then there will be no remainder. Right? So write the integer portion. Integer portion means only 22. 22 into 2 is 44. That means there's one remainder. To find remainder, you have to write the integer part only. Okay, integer part only. Then remainder, you have to write as 1 or 0. And there's another thing. So note this. So if this number is odd, then remainder is always 1. This is how you check the accuracy. If this number is even, remainder is 0. If it is odd, here this one is odd. If it is odd number, remainder will be 1. If it is odd number, remainder will be 1. So there's a relation between odd and even. If it is even number, remainder is always 0. If it is odd number, remainder is always 1. That's how you are going to check whether this is correct or wrong. Okay. Now let's go for our example. I will give you like, okay, I think 2 minutes enough. Just do this calculation, convert this number to binary, octal and hexadecimal. Try to convert this number to binary, octal and hexadecimal. Okay. Now you can start. Let me show you the steps. Then you can decide whether you have any question, you can ask them. So let me show you the steps first. Right. Okay. So it's like this. In binary, 79 divided by 2 is equal to 39, and remainder will be 1.
Remainder will be 1.
Yeah. Then
39 divided by 2.
Okay.
19 remainder 1.
19 remainder 1. That is true. Then
19 divided by 2.
2,
9 remainder 1.
9 remainder
Remainder 1.
1.
Then 9 divided by 2. 4 remainder 1.
9 divided by 2 is 4 remainder 1. Yeah, that is true.
And then 4 divided by 2. 2 remainder 0.
4 divided by 2, 2 remainder
2 0.
0. 2 divided by
2
2,
divided by 2 1 remainder 0.
1 remainder 0. Okay, that's how you calculate. So one has question. Can you ask that?
Sir, I joined now. So what?
Right. It's okay. So you join now. I have given a question, and this is the only thing we just discussed from the last day. We were just revising. Can you hear me? Hello.
Yes, sir.
Yes, sir.
Okay. We were just revising. We were just discussing the last week lesson, and I have given one example to do a calculation. Right. This is that example. And 79 to binary, octal and hexadecimal. 79 we have already converted. The method is divide by the base and write the remainder. So this is first example. So value will be, you have to take from bottom to top. 1001111 is the answer. Most of you have got that. Right, most of you have got that. That is correct. Right, I think no one actually no one got question from this area. Convert it to binary is easy. Is that so? Or anyone still feel difficult? කාට හරි තාමත් අමාරුයිද binary කරන්න? කවුරු හරි ඉන්නවනම් කියන්න, then I can repeat. Yeah, I think everyone okay with this. Converting binary is easy. Then octal. 79 divide by 8. Divide by 8, you know, 80 divided by 8 is 10. So 79 divided by 8 is 9.
9.
Then remainder is 7. Remainder is 7. Then you have to check 9 and 7 whether these digits are belongs to octal. So this is octal number system, no? 0, 1, 2, 3, 4, 5, 6, 7. 7 is in octal, but 9 is not in octal here. 9 is not in octal. So you have to divide again. That's how you find that whether to divide again or not. Understood? If all the digits are already in the base, then no need to divide. So here 9 is not in the base. 9 is not in octal. Here 9 is not in octal. So you are going to divide. 9 divided by 8. So will be 1 remainder 1, no?
1.
Yeah, 1 remainder 1. So the value is 1. Yes, 117.
Excuse me, sir.
Yes.
Sir, when we are converting a number to binary only, we should put 2 in the bottom of the answer, no, sir?
Yeah, if it is binary, you put 2. If it is octal, you put 8. If it is hexadecimal, you put 16. If it is decimal, you put 10. That is the base. Understood?
Yes, sir.
Okay. Right, then 16. So 16, some had the problem. Yes, 16, some had problems. So let's divide by 79, divide by 16. So it is 4. Remainder is, yeah, remainder is 15.
15.
Yeah, 4 remainder 15. 4 remainder 15. Then what you're going to do? So 4 is in hexa. You can see 4 is in hexa. Valid. Then 15. 15, is it in hexa? 15 in hexa, yes.
No, sir.
No, sir.
Yeah.
Yeah, it's
It's
there.
in alphabet.
Only thing is, yes, only thing is, it is letter F, but you know, value is 15. Value is still 15. So 15 is there in hexa. It is F. So 4 is there, that is 4. 15 is F. So how we are going to write this is 4F in hexa. So that is the mechanism. I think we have solved the issue. Yes, you have to use letter F. You can't write 415, okay? That is invalid. You can't write 415, that is invalid. So then we are going to write like 4F. Okay, this is used in many places. This is used in many places. So let me show a small example, very small example, but this one we are going to discuss later. Grade 6, 7 සමහර විට ඔයාලා මේක කතා කරලා ඇති. But anyway, I'm going to show you this, but if you don't know, don't worry. This is not grade 8. I'm going to give you an example only. Let's say you have HTML page or web page, and you have head section in web page. This is not relevant to you. Don't worry. I'm going to show example only where this hexa and hexa used. Then you have title. Let's say this is hello HTML. Then you have body section. Sorry.
Website එකක් හදන්නේ තියෙනවා sir.
වෙබ්සයිට් එකක් හදන විදිහ හැබැයි ඕගොල්ලන්ට මේක මේ පරණ grade වල තිබිලා මිස් වෙලා ඇති සමහර විට, but we are going to learn this in grade 8 as well. මේ පාඩමේදී නෙමෙයි අන්තිම පාඩමේදී. but අපි පුළුවන් වුණොත් කලින් ඉගෙන ගමු. මෙච්චර කල් වෙනකන් ඉන්න ඕනේ නැහැ. If we have time we will learn earlier. So body, I'm going to say BGCOLOR equal red, green, blue. So this is hexadecimal code. First 2 digits says red color. Second 2 digits green. Third 2
Green.
digits blue. Right? Red, green, blue. So which has the maximum? Red or green or blue?
Red.
Red, yes, because first 2 digit red. Red is FF. F means 15, no? 15, 15 in hexadecimal. This is 0. This is also 0. This is hexadecimal code. Let me save this. Let me save this. I'm going to save this in desktop. Let's say test .html. I'm going to save this in desktop. Okay. Then let me open this. Yeah, let me open this one. This is our test.html. Yeah, this is test.html. Let me open this. This is red color web page. So we have given the command or we have given the instruction. So that's what I want to show. I don't want to show you how to create web page now. We will learn that later. But මට පෙන්වන්න ඕනේ hexadecimal වලින් තමයි අපි මේක කිව්වේ. That's why we are using these number systems. So hexadecimal F means, you know, it is decimal 15 and binary. So we learn later, right? We learn later. So likewise, you can combine colors. Let's say red, maximum red and maximum green. It will create yellow color. Okay. Maximum red, maximum green, maximum blue. Can you tell me the color? All colors maximum. What is the color? Red maximum, green maximum, and blue maximum.
Purple.
Purple.
So in science, have you used prism?
Black. Orange.
Oh, telling various colors. Okay. In science, have you used prism?
Yeah.
Prism
Yes.
to see the rainbow colors and all. When light is
Yes.
transmitted, transmitted through the prism, it will create rainbow colors, all colors.
Yeah.
Then if you combine all colors, what will be the color? The other way.
White.
It should be white. Right. You give the correct answer. It is white. Right. In all colors, you know, rainbow, when you transmit white light, right? White light through prism. So when you transmit white light through prism, so it will create here, you can see the image, it will create all the colors. Right? So theoretically, if you combine all the colors and send to the prism, and it should create white color. So here that's happening in this web page. When you combine all colors in maximum way, that will create white color. All colors maximum way, that will create white color. In the other hand, no colors means 0 red, 0 green, 0 blue, no color means yes, no red, no green, no blue. Then color, what is the color?
White. White.
White.
White.
All the colors, it's white.
Black. Black.
Then no
Black.
colors, yes, no colors, it's black. When there are no colors, it's black. In black web page, you can write in white letters like font color. Font color, you can give like hash FFFFFF. Then hello. This hello will be written in white color. This is how you instruct the computer. Computer එකට උපදෙස් දෙන්නේ මේ වගේ. To do that, okay, font color. Sorry, font color. This is how you instruct the computer to do something, and you can see hello in white color. Let's increase the font size of hello. This we will learn later. You have this in your syllabus. Organized syllabus එකේ මේක තියෙනවා. අපි මේක පස්සේ ඉගෙන ගමු. How to create web pages and all. That is in HTML, but not now. We'll learn this later. But by that time, you should know this. By that time, you should know hexadecimal, binary, octal, all these things. And similar to this,
Grade 7 also we learn.
grade 7 also, you had just final lesson, last one. Internet and email, internet and its services and web. It's there in grade 7, but some of you have missed grade 7, unfortunately, due to this pandemic situation. For them, actually, we have given a free chance to come for grade 7 class without paying. So you can come for free if you missed that. Okay, so let's go back to the lesson. So we were discussing about number systems and numbers conversion, and we saw where it was applicable, right? Okay, we saw how we are applying these things and all. Okay, then let's do this other way, right? Oh, let's try a few examples before we move. Let's try a few examples. Asindu, I think I have to turn off annotation. Annotations, that means you are writing in my stream. Let me clear all this and stop the annotation part. Because when you touch, maybe when you touch your screen, mobile phone, it start drawing in the screen. That is usual because that is the nature of app. Because I have not turned off annotation. Don't worry, it's not your mistake. Okay, right. So let's do few more. Try to calculate this one. I'll give you a number like 1023 in decimal. Find out what is the binary value of this one. 1023 in decimal. Try to find what is the binary value. I'll give you again, okay, 1 minute, 60 seconds. 1 minute means 60 seconds. Yes, more than enough. Do this quickly.
Finish, sir. Please,
Okay. Yes, that's right. So let's see. 1023. You have to divide like this. So I'm going to use this. I'm going to use the traditional method, which is going to use in your books. Basically, you write 2 here, then you are going to divide by 1023 and write the remainder in front of it, and that is 2 divided by 1000. It's 1. Then again you're going to write like this. Sorry. Okay, I'm going to draw this. Then 1023 divided by 2 is 512. 511. Remainder 1 divided by 2 is 255. Remainder 1 divided by 2 is 127. Remainder 1 divided by 2 is 63. Remainder 1 divided by 2 is 31. Remainder 1. Then 15. Remainder 1. Then divide by 2 is 7. Remainder 1. Then 3. Remainder 1. And it is 1. Remainder 1. So what is the traditional method? You are going to use this kind of annotation. So this kind of thing. Again you divide by 2. 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 Divide by 2. Divide by 2. Divide by 2. Then you take here to here. How many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ones. Correct?
Correct.
Yeah, 10
Yes,
ones.
yes.
Yes, sir.
Then can you try the same, convert that to octal and hexadecimal? Convert to that to octal and hexadecimal.
Sir, I got only 9 ones.
Should be mistake.
Finish, sir.
Yeah, should be mistake. So if you have done correctly,
Sir,
you-
how many are there? 10.
10.
Sir, how many are there?
10.
10.
10.
Then my one also 10.
Yeah, 10.
Okay, sir. I found 10.
Yeah, you found the mistake, right? Okay, that's right. Okay, can you convert to hexa and octal and hexa? The same now, octal and hexa.